Hello, welcome to Electronics Education. I am Vincent Chang. In this lecture, we are going to wrap up the common base amplifier. Common base amplifier, part 3, derivation explained. Now, this is the circuit we have studied in the previous lecture. The first lecture focusing on the analysis by inspection. The second one, we focus on the T-model expansion. So for the T-model, this is the expansion, the small signal equivalent circuit we have studied in the previous lecture. So now, here's the parameter. The first parameter, input resistance. So the input resistance is the parallel combination between the capital R and the lowercase r. What about the voltage gain? It's the Ohm's law on the right and divider on the left. So pay attention to the phase. VL over V pi, negative GM times RC in parallel with RL. And the second term, the V pi divided by Vs, is the ratio, right? It's the red and RS to divide voltage, and in the denominator is the red. But pay attention to the phase, because it's negative V pi. So there's additional negative sign. A negative and then the second negative is going to cancel out the first negative GM, the negative. And then this is the outcome. Right? So let's repeat this. The second term, V pi over Vs, is this. Rin, the effective resistance of the red block, divided by the total series resistance, voltage divider. And the first term, VO over V pi, is what? It's negative GM times RC in parallel with RL. And canceled out the negative sign, give us the outcome. This is the final small signal voltage gain. What about the output resistance? The first step, take out the signal source. Take out the signal source. Right? The answer is shown on the slide. I out equals RC. But you might have, what about the voltage control voltage source? Let me rewind. What's the output resistance? Someone said RC. But what about the voltage control voltage source, current source, GMV? What about GMV pi? How you handle GMV pi? So first step, if you cannot answer this question, how are you going to handle GMV pi? Then we need to do step by step. Make sure you have a strong foundation, okay? The first step, set Vs0. To take out the signal source. Short circuit the external signal source. First step. And then, what's next? Then ground. Look at left hand side. Ground. So no current. There's no current. There's no current. So V pi is 0. There's a voltage across the RE. No current, no voltage across RE. So voltage control current source, V pi, GMV pi. When V pi is reduced to 0, what's the consequences? What's the effect? The GMV pi equals 0. When a current source, the value of a current source equals 0, that means what? That means the current source is effectively open circuit. It's effectively can be open circuit. So the answer is in fact RC, no problem. No problem. So this is the takeaway, analysis by inspection. I still want to, once we have the foundation layout, the T model expansion, so I want you to go higher again. What's the input resistance? What's the input resistance? Analysis by inspection without relying on the small signal equivalent circuit drawing. Okay? So look at the original circuit and be confident. What's the input resistance? The capital RE in parallel with the lowercase 1. IE, that's the first one. What about output resistance? Now RC. How to handle the GMV pi? Can be open circuit. Can be open circuit. So your brain probably have to run very fast. Why the voltage, the GMV pi can be open circuit? Because Vs 0, V pi 0, and GMV pi 0. The value of current source is 0. That means the current source can be effectively open circuit. What about the voltage gain? It's this. It's Ohm's law, based on the Ohm's law and the dividing rule. GM, C, just follow me. Follow my thinking. Okay? Just sync my thinking. Negative GM, CL, and Rin divider, RS. Rin, RS. Negative V pi. Negative cancel out negative. This is the answer. So I said this is the negative V pi. And there is a GMV pi. Sorry. Let me try to go back. I don't know what happened. Hold on. Something happened here. Sorry, I accidentally touched some of the buttons. So then, let me start with this, the analysis by inspection, right? So the input resistance, output resistance, and voltage gain. And then negative V pi, the GMV pi. So V over V pi, negative GM, CL, and then dividing ratio. So if you have any question, then you go back and check with the small signal equivalent circuit, and the answer will be very clear. This is the first takeaway. The second takeaway is actually a practice. So I want you to practice is to take a screenshot. This is the integrated circuit, an IC common base amplifier. The circuit, the previous circuit is biased, is the discrete circuit bias. But this is the integrated circuit bias. The transistor is biased by a constant current source of 0.25 milliamp. A constant current source of 0.25 milliamp. So just answer, what's the small signal voltage gain? What's the small signal voltage gain? VO over Vsig. VO over Vsig. I'll give you 3 minutes. Try to solve this. Solve this in 3 minutes. So what's your answer? What's your answer? Input resistance. What is input resistance? 100 ohm, right? The RE. Thermal voltage 25 millivolt divided by 0.25 milliamp, 100 ohm. So the first factor, GM, parallel 3 ohm. So transconductance 10. Bias current divided by thermal voltage. 10 milliamp divided by volt. So 10.3. 10.3 and divider. Input resistance 100 ohm. RS plus Rin. 200. Half. 10, 3, and 0.5. 10 times 3 times 0.5. So the answer is 15. So that's the level I wanted to go. I hope you enjoy. We have come to the end of the common base amplifier. This lecture is also the end of the 3 bipolar junction transistor amplifiers: common emitter, emitter follower, and the common base. I hope you can be more confident when you face this kind of circuit analysis. Thanks for watching. I see you in a MOS transistor amplifier.